So this is called mistakes in new scientists' teaching of relativity. I've just done this course on New Scientist Academy. It's called Beyond Einstein, Making Sense of General Relativity, and the ideas it inspired. And I found the course to have many mistakes in it, and there's too many to deal with them all, so I only deal with just a few of them. The basic idea for such an education course is to try to make it as simple and easy as possible for the students, i.e. those doing the course, to understand. In other words, to dumb it down, and dumbing it down, that completely distorts the subject and misrepresents it to the students, allowing the students to come away from such courses as believing things that are false, i.e. such courses don't deal with the subject properly. So I'm dealing first off with this slide from New Scientist, which they gave on the course, and what Einstein is saying there is really just waffle and not really relevant. I'm just concentrating on the diagrams. So this is the diagram. It's referring to the principle of equivalence, and it says a general observation that correctly applied acceleration is indistinguishable from the action of gravitational force. And it says this means that inertial mass and gravitational mass are exactly the same. A consequence of the principle is that objects of any mass or composition accelerate at the same rate in a gravitational field. And what the picture shows you is two boxes, a person in each box. In the left hand box, the force on the person is from gravity, and the earth is represented there by a circle. And of course this is a distortion a bit, because you're representing the earth as being a very small circle. Really, it's a really big object. And then in the other box on the right hand side, you've got the man in the box undergoing a force from some sort of propulsion, such as a rocket. However, they're not the same thing. And in the first case, you have the man in the box, and he has gravity directed towards a point at the center of the sphere, i.e. gravity acting towards the center of the earth. And allowance has to be made that this is an exaggerated picture, but the lines of force are going towards that center of the sphere. While in the second case, where you've got the man in the box being pushed upwards by a force such as by a rocket, those forces are not converging to a point. If the earth were flat, then gravitational lines would be like this, all parallel, and that's representing the force of acceleration by gravity. but the Earth is not flat, so the gravitational lines are directed towards the centre of the Earth. A person at one place will always find the force of gravity directed towards the centre of the Earth, which would be the centre of gravity, approximately. So the two situations are not the same. New scientists should be saying, ignoring the fact that in the first situation, acceleration is directed towards the centre of gravity of the Earth, and in the second situation it isn't. And it should then say, if then ignore that, then you can treat them as equivalent. What that amounts to in religious terms is a sin of emission. It is something that should have been said but wasn't said. The way educators usually try to wiggle out of it when it's pointed out to them that they have committed a sin of omission is by saying that they were only trying to give simple explanations and were not going into a full explanation. But they usually don't state that is what they're doing when teaching. What they give is not the full explanation, same as what New Scientist does. So they omit giving a full explanation, and they also omit telling you that they're not giving a full explanation. So they're committing sins of omission on top of other sins of omission. And New Scientist, of course, then makes its mistake worse by referring to the following text. This is the article that New Scientist Academy refers to when it's doing its course. It's an article by Stuart Clark. And that paper shows the following diagrams, where you've got a rocket on the left with a person standing effectively in another box, and on the right you've got a person standing in a box on the Earth. So you've got forces in both situations, and you've got acceleration in both situations. And the diagram does not show acceleration directed towards the centre of Earth for the man in the box standing on the Earth. And that is unlike the diagram which New Scientist Academy showed earlier. In that diagram, they showed the force of gravity going towards the centre of gravity, converging to it, but in the paper they're referring to doesn't show that, i.e. there's no consistency in the diagrams being presented. I could go on complaining about everything else that has been taught, but I will just deal with one more example. And so you've got this from the New Scientist course as well. On the left hand side you've got an image of something that's supposed to be Einstein, and that's not really relevant. We need to look at the diagrams on the right hand side. So this is the diagrams on the right hand side. You've got 3 situations, and what it says is the path of a light beam in 3 different types of reference frames moving with respect to the person outside the elevator, the box in other words. The light path shown is what the person inside the elevator, i.e. box, sees. Under large acceleration, the beam of light will curve downward. It should also do that in a region of strong gravity. So I want to concentrate just on the first 2 situations. The acceleration case presents other problems, and I'm not dealing with that here. I'm dealing with the situation here where you have the 0 motion case and the constant velocity case. And my point is, this only shows you what happens when the light source is outside the box. The person shining the light is outside the box, and I don't think that's really that clear in the picture that the light source is outside the box, but that's what the situation is. The light source is outside the box, so the light being shone into the box, when there's 0 motion, the person inside the box sees the light go straight across from one side of the wall to the other. While in the other case, where the person in the box is moving upwards with constant velocity, he then sees the light coming in, moving downwards, as shown here. When the light source is inside the box, then there shouldn't be bending like this. In that situation, the light will just move from one end of the box to the other without bending down. Now, your scientist doesn't tell the student that, so it's another sin of omission. Not being told that, then a student could look at the situation below and easily be deceived into thinking the bending occurs when the light source is outside the box or inside the box, when it doesn't. So the methodology of the educators to try to present things dumbed down, and when they do that, they leave things open for the student to deceive themselves. And that's the end of this short video. Thank you.